I'm Jasmine Smith, and I am doing a test wrapper for test number 1 for Physics 2211. I'm doing problem 3, and the problem means you're navigating a spacecraft far from other objects. The mass of the spacecraft is m. The rocket engines are shut off, and you're coasting along with a constant velocity of 0 vi 0. As you pass location xi00, you fire thruster rockets so that your spacecraft experiences a net force of negative f2f0 for t seconds. The ejected gases have a mass that is small compared to the mass of the spacecraft. You then turn off the thrust rockets so that no net force is acting on the spacecraft. Where are you t seconds after the rockets are turned off? So I started off by putting everything on the top as like what is given. So t equals t time, f net is the force that's given, the initial velocity, the initial position, and these are just equations that I'm going to need to find other parts of equations. So what I did, so at the end of the thrust, you have your final velocity, which is vi, which is this equation, vi plus f net over m times delta t. And so what I did is I just plugged in what your initial velocity that's given and your force that's given over m times t, which is your change in time. So what I did is I just distributed this out. So your final velocity at the end of the thrust is just negative ft over m vi plus 2ft over m 0. So next, you have to calculate the position at the end of the thrust using that final velocity. So I called this RF1 since you have to find the position after the thrusters are turned off too. So RF1 equals, and then I just call it RF, just shorthand I guess, lazy. RF equals RI plus V average delta T. Okay, and so changing V average to VF plus VI over 2 times delta T. That's what I did here. And so I just plugged in what I already have. And that is the initial position, which was given, plus that, plus the final average, plus the, the final velocity plus the initial velocity divided by 2 times delta t again. And this is just rearranged so that it's easier and I could distribute things easier. So once you distribute that all out and simplify it, then you get to x initial minus ft squared over 2m vit plus ft squared over m 0. So the final step to this is finding the position t seconds after the thrusters are turned off. So I call this RF2, and this will be the final answer. So RF2, again, I'm using RF2 equals RF from here, plus final velocity times delta t. So, okay, what I did here is I plugged in this, what I got from here. So this is this, plus the final velocity from here, times delta t, and I went ahead and distributed that. So this is already the VF times delta t here. And for the final part of it, I just had to distribute everything out. And this is your answer. And this could actually simplify further to like 2 times this, but your final answer is, this is supposed to be xi right here. Xi minus ft squared over 2m minus ft squared m. 2 vi, 2 times all of this, just to make it easier to say. 2 times that, 2 times vi times t plus ft squared over m, 0 is the final answer.